The concept of vertical scaling, often referred as scaling up, this process involves adding more computational resources, such as CPU and RAM, to a single server, and a single server is the focal point of vertical scaling where all upgrades and enhancements are applied. And inside the server, we have CPU and RAM. They are primary resources, and they are increased during vertical scaling and the process of scaling up, which is adding more power to the server in terms of CPU, RAM, and storage, and other resources. Hard limit illustrates the intrinsic limitations of vertical scaling. This is a finite point to how much you can upgrade a single server's hardware, and beyond this point, it is impossible to add unlimited resources, and the single server represents the simplicity of vertical scaling. It is straightforward because we are only dealing with one machine. Limitations is the critical drawback of vertical scaling. You can only upgrade a server to a certain extent, and after it's reaching its maximum capacity, you cannot further enhance the server's performance. In vertical scaling setup, users connected directly to a single web server. If that server went down, users lost access to the website or application. Or when too many users access the web server simultaneously, it could reach its load limit, which resulting in slower response or failed connections. Lack of redundancy and failover. A single point of failure. If the server goes down, the services it provides, like a website or an app, will also go down. So this illustrates the lack of failover and redundancy in vertical scaling, which making it a risky operation for high availability systems. So in summary, vertical scaling offers an easy and straightforward approach to increasing server capacity. Its limitations in scalability, redundancy, and failover capacities are significant drawbacks, especially for larger or critical applications. Let's try to illustrate the concept of horizontal scaling, also as known as scaling out. So this approach is particularly beneficial for large-scale application due to the limitations inherent in vertical scaling. So multiple servers signify the pool of resources which are available in horizontal scaling. So unlike vertical scaling, which focuses on single servers, this horizontal scaling involves adding more servers to the system, which is by use load balancer. The load balancer is a crucial component in a horizontal scaling. The load balancer efficiently distributes incoming network traffic across multiple servers. So this distribution ensures that no single server bears too much load, which can prevent server overloads and minimize downtimes. The load balancer's role is directing users' requests to different servers, which is based on factors like current load, server capacity, and health. And so the horizontal scaling is the expansion of capacity just by adding more servers. The load balancer addresses these problems by distributing traffic across multiple servers, so it not only manages the load more effectively, but also provides redundancy. If one server fails, the load balancer can redirect traffic to the remaining operational servers, thereby maintaining the availability of the website or applications. So, in summary, the horizontal scaling with the aid of a load balancer compared to vertical scaling, it offers a more robust solution for larger scale applications and providing scalability and improved load distribution and great fault tolerance.